All right, so learning goal today. The student will understand how the area of a circle is related to the circumference. So again, today area means everything that's inside of a circle. Circumference is the distance going around. We're going to see if there's a relationship between those two. All right, so starting off here. Okay, so again, when Digits puts problems in there, I'm like, I've never heard of this. So I went and Googled it and found a Google image of it. So I guess it's a real thing. It says the world's largest coin is a giant gold coin minted in Canada. It has a circumference about 61.9 inches and weighs about 220 pounds, which is the size of a grown man, would be 220 pounds. What is the area to nearest square inch that faces this coin? So I looked at it. How much does it say that coin is worth? $1 million. Because think about that. That's 220 pounds of gold, basically. Well, I think it would probably be pretty hard to seal, don't you think? I have a feeling it's probably like...
You can't just find that
yeah,
in your purse.
You just put it in your pocket and walk out. Like, 220 pounds, you'd have to, like, roll it out. But I was like, look at that. I didn't even know that was a real thing. All right, how are we going to figure out the area to the nearest square inch, then, if we know the circumference? Are you really up to it? That was a science term. All right. What do you guys think? Should we start with what we know?
We know this is
the circumference times pi?
no.
Let's start with what we know. We know the circumference is 61.9. Okay, our ultimate goal here is to find area.
So divide that by 2.
Divide the circumference
By 2.
What are we always supposed to start with? Area, our formulas, right? Okay, so we've been working with 3 formulas, or really 2 formulas. We've been working with our circumference formulas. And then we've been working with our area formula. Okay, so look at those formulas. So we know circumference. Our goal is to find area. What do you think we need to do?
Divide the circumference by pi.
Okay, but why?
Size, you can get the diameter and divide the diameter by 2.
Okay, to get the radius. So which formula? First one, middle one, or last one are you starting with?
Middle one.
Oh, you want to go to the middle one now? Yeah? Okay. So let's start with that middle formula. So circumference equals 2 pi r. Do we know what the circumference is?
Yes.
Yes.
61.9.
61.9. We can plug in the 2. What are we supposed to use for pi?
3.14.
3.14. Do we know what the radius is? Why do I need to know what the radius is?
Size, you can square it.
So I can square it and multiply by pi because that is what we need to find area, right? To find area, I need to know the radius so I can square it and multiply by pi. So I need to find the radius here, which is why he was saying divide. Okay, so what I would do, instead of dividing twice, I like to just say this is 6.28 r, and then divide both sides by 6.28. Okay, so what would that be? So 61.9 divided by 6.28 gives me, long number. So let's see here, about
8.6.
Let's go 8.6 is my radius. Does everyone understand why I just found radius? No? Why not? What's wrong?
Why don't you just divide it by pi? But how do you know that?
Because you can't divide by pi because that won't give you the radius.
Oh, I get it.
I find radius first. Now I know radius. Now what do I have to do?
Square it.
Plug it back into this one, right? So square it and multiply by pi. Okay, so now I'm going to plug it back into this formula. Pi r squared. So area equals 3.14 times 9.86 squared. And I'm going to just go to my calculator and do 9.86. So 9.86 actually going to put 305 would be the nearest square inch, and that would be the area of my coin. And what was this in inches? Okay, so area equals 305 square inches. Questions on that? Is that okay? It is a long process. Alright, I'm going to let you guys try this one more on your own and see if we're really getting it or not. Alright, so I went ahead and started this one. I've got my circumference. I need to find my radius so that I can find the area. So I wrote out my formula and I was ready to divide. So what is 22 times 6.28? Okay, so yeah, roughly 3.5 would work. So it was 3.503. So 3.5 is good. And now I'm going to plug that into my area formula. So area equals pi r squared. So my radius is 3.5. I'm going to square it and times it by pi. Alright, so what is 3.5?
38.465.
3.5 times 3.5? And that's 12? Yeah, times 3.14. And that gives me 38. What did it tell me to round to? It said approximate area. So I would probably go with 38.5. I wish they would tell us more specifically here to round, but somewhere close to that.
If I said 39,
I think it just really depends on the question. I mean, normally it's going to tell you what to round to, like in the little blue box, but usually approximate, I would still probably go out to at least one decimal place, but I wouldn't say it's wrong. Okay, did we get that okay? Everybody's good with that before we move to the next part? Okay. All right, here's the next part. All right, so we're going to start to look at a pattern. Remember, the learning goal today was how was area related to circumference. So it's going to start us in this chart, then we're going to have to look for a pattern. So first of all, it says you have a radius of a circle, which is 4. Then it asks to find the area. So remember, for area pi r squared, we're putting in 4 and squaring it to get the 16, and then they're leaving it in terms of pi. So they just left it 16 pi. And then they said to find the circumference. So with circumference, we go 2 pi r. So what they're doing is they're taking the radius, which is 4, multiplying it by 2, and they're keeping the 8 pi. If you don't understand this, you're going to mess up all this. All right. So then what they did is they put the area over circumference. So 16 pi over 8 pi. What do you get when you have the exact same thing over the exact same thing? 1. So actually the pi's cross cancel here. That's why a lot of times we like to leave things in terms of pi. So the pi's cross cancel and become 1 whole. And then 16 over 8 reduces to 2 or 2 over 1. Okay? So let's try the next one together. And then I'll give you a couple, and then I'm going to have you look for the pattern. Okay, all right. So we have area is 6. Okay, so if our radius is 6. All right. So what are we going to get here for area? 36 pi, right? Okay. What are we going to get for circumference? 12 pi. So now we have 36 pi over 12 pi. What is that going to reduce to? 3 over 1. All right. What are we going to get for 8 for area? 64 pi. For circumference, 16 pi. And for our ratio, then we get 64 pi over 16 pi. 4 over 1, right? So 4 over 1. Okay, what about the last one? 100 pi. Alright, 100 pi. Let's see, what's the next one? 20 pi. Then we get 100 pi over 20 pi, which is how much? 5 over 1. Okay, so we need to know, is there a relationship between, what do you see, or what do you see in this table? What do you see, Samantha? Okay, the denominators are all 1s, which means there's a a pretty good relationship here. That's good. Okay, what else do we notice? Eric? You lost it. Okay. Yes.
I have a question. Why do you get the 8 pi and the circumference? Why do you get the 8 pi, the 12 pi, and the 16 pi, so on?
How do I get that part? Is that what you're asking? Because I'm using this formula right here. So if I put the radius, if I say the radius is 8, 8 times pi times 2 would be 16 pi. Anything else? Yeah. Okay, it does go 2, 3, 4, 5. Okay, that's another pattern. Okay, what about the relationship between this number and this number? This number and this number. Okay, what's another way to say divided by 2? It's half, right? Okay, so what we're looking at here is, see if you agree, that if you take the area over circumference, it is always half of the radius. You take the area over circumference, which is this, A over C, you always get half of whatever the radius was. Does that make sense?
Yeah.
Yeah? Because we're going to have to use this formula. Got it? Yeah? No questions? You guys are at my class. Why is that? It's just another one of those relationship pieces. Just like, why does pi work? You know, like each time we measured and it worked every time. So this is another example where this is a relationship between circumference and area. Can you think about this? What happens as the circumference gets bigger? What happens with the area? Gets bigger. And those two are going to have a relationship, right? So that's why that's the relationship. It's always going to be half of the radius. Yes. Exactly like this.
They have a lot of spare time.
Yep, that's exactly what happens. Yep. All right, so let's look at this next one. All right, the ratio of area of a circle to the circumference of a circle, A over C, is 11 to 1. What is the circumference of your circle? Leave your answer in terms of pi.
22.
22? Yeah? Okay. 22. Because here's the way I would look at it. If you're like, what? This A over C is 11 over 1 equals 1/2 R. So 1/2 times what gives you 11?
22.
22. Does that make sense? Okay. Whoops. All right, so we're going to do some practice on this because I want to make sure you have this. So I want whiteboards. If you want it projected up here, I will leave it up here. If you'd rather have it on your computer, that's fine. I don't know if you need to save your battery.
Do we need our computer?